Hey everybody, I was going back through some of the videos that I recorded for the series and I realized that I never got Ppp authentication to work. So I was like, shall we fix? And I said we shall. So basically what I did was I went back through, and it doesn't have to be anything fancy, it doesn't have to be some sort of weird algorithm or anything like that, but I wanted to show you what I did because I had to play with it before. Usually I'll make sure something works before I do it, and then I'll do it. Then actually show you how it actually works, because I know for a fact it's going to work. Because as a trainer, I like to have that aha moment, and you don't always get that. So for me, it's more of a, well, if I don't test it before I do it, then chances are something's going to go funky on me, and we're going to have problems. So that's okay though. But what I want to show you is what I have here. I do have authentication working, and it took me a minute to figure out what the problem was. I was wondering where I was going wrong. Well, I couldn't figure it out because the passwords were the same, and I was like, so I did a debug, and I did a long debug. Matter of fact, I did a debug so long that I actually had to reboot a router because it was so long. But because I couldn't get R1 to break out of it, and that will happen. Make sure when you do a debug, you do it from user mode, which is down here with the pound sign, privilege mode, because then you can type in all, hit the up arrow once, and hit all to stop debug all, because if you don't, it'll just keep going, and going, and going, like the Energizer Bunny. And eventually you have to pull the battery out of the Energizer Bunny to make it stop. Well, I had to turn the router off, turn the router back on, in order for it to do what it had to do. So, that being said, what I did, and all I did, is this. Show run pipe include user. This is all I did. On this guy, I did username R4, password 0 Cisco. Same thing with this guy. I did, where did I put it? Oh, right here. Show run include user, username R1, password 0 Cisco. That's all I did. And I bounced the interfaces before I did it to make sure that I knew they were down. And like if you hadn't put authentication in there yet, and then you threw authentication in there and it goofed things up like it did with me, that's all I did. So it's actually really, really simple. It's nothing major. As you can see, show IP interface multi-link, or show interface. Like, why is it not working? Interface multi-link 1. And there we have it. We are up, which is a good sign. We're load balancing, and we're good to go. So, the last thing I want to talk about before we end this series is this. This fancy thing called a VPN. What is a VPN? Well, I will explain a VPN for you in just a moment here, sir. And let me just get this stuff saved. And we're going to go from here. A VPN is a way of tunneling through the internet from wherever point you have on the internet. So let's say, for instance, let's pull up Paint here and go voila. Well, this is for my layer 3 troubleshooting earlier. I guess I never... Let's get rid of all this. Start over fresh. Voila. Let's say, for instance, we're going to make something cute here. I'm just going to draw a circle here. Let's say this is the internet. Okay? And the internet, let's say the INT. Oh, that's too horrible. T. Internet. You have a remote site here that connects into the internet via that. This is the internet cloud. Version 4, version 6, whatever else it might be. And then you have a link going off this way to a branch, this going off to a branch, and then this guy going off to a branch. So you have a circle there for a router there, and a router here. What this does, and I'm not going to configure a VPN, I've never actually done it, is you have HQ over here, and then you have 1, 2, and 3. So, what you do with this is a VPN well, actually, let's take one step back. Most of the time, you would do a leased line, so a T1 or a point-to-point connection between each branch. So you'd have a circuit from here to here, and actually, that's what I'll do is I'll do that to that. It'll be one circuit, and do that. Well, actually, just kill that guy. Go from here to here, and from here to here. Okay, that would be how you would do it normally. You would have it set up. That's how it would go. Everybody would be happy. Well, not today. Today, lease lines are expensive. They don't have the bandwidth that they used to. Most people have faster internet at home than they do at work. So, VPN. A VPN provides you a highly secure connection on a point-to-point basis between wherever you're at and your internet connection to anything in the world that has the capability of completing that circuit. Now, most places they'll have a VPN concentrator, and that thing where the VPN concentrator will be responsible for doing the authentication, the encryption, the integrity, all that other good stuff. But what a VPN does is it does this. It allows you to have teleworkers. You know, you might have a guy over here that works from home. You know, draw a computer. I'll draw a laptop. I'm not a drawing major, but I'll do my best. Okay, that's a laptop. Okay, I'll just draw a little screen inside it. Okay, we have our laptop. So, the laptop, actually let me, I started drawing, I'm like, oh, I can draw. Yeah, I should stop while I'm behind. Okay, so there's our laptop. We have our laptop, and we have our PC computer over here. You know, we'll put a little floppy drive here, power button there, a little monitor up here. Should have been a drawing major. Yeah, not. But anyway, so we have our branch offices, and we have, say, 2 teleworkers. We have a guy that works from home, he's a programmer, and this other guy, he's a salesman. So he travels around the country trying to sell the company's product and trying to drive more business, trying to pull more business in, getting clients, that type of stuff. So, in order for these guys already have lease lines back to HQ. But in a recent hiring spree, the current network engineer was replaced with this, I should say the former network engineer was replaced by this new network engineer who's younger and has a different theory on how things should work. So he goes to the boss and says, hey, we're spending $30,000 a month on dedicated connections to the branch offices. And the boss goes, yeah. Well, what if I could save, say, $20,000 a year, or $20,000 a month, by setting up VPN tunnels to our remote sites that would provide us, one, more bandwidth, so you can get more production done during the day, and these connections aren't just point to point. And the boss goes, okay, you've got my attention. And you say, well, these branch offices are only allowed to talk to us. And what ends up happening is information comes in across the lease line from the, say, he's got 2 PPP connections, he's got 2 T1s, and he's got 3 megabits back here. Well, he's only got a circuit to here. So if he wants to send information to HQ that needs to go to branch 3, HQ's got to fire that information back out to branch 3. So it's going to be a multi-point to point-to-point connections. Point to multi-point. So in that regard, you're going to have a hub and spoke environment in order to achieve this. Well, I have a better idea. And the boss goes, okay, what's your idea? What if we set up VPN tunnels, which are secure tunnels through the internet so that nobody can see what's going on inside of the tunnel. They don't even know it's there. They just see traffic flowing. They can't tell what it is. And these tunnels are able to be brought up no matter where you are. We don't have to have T1s going to every public IP address that's on the internet, only the ones that we need them to. These leased lines are there is no lease line. All we have to do is at this location is configure a VPN tunnel from this guy's interface, so this connection right here, to this guy, and that's all we have to do at that location. Then we do the same thing from 2 to 1, 1 to 3. So not only does 1 be able to 2 can talk to HQ, but 1 can talk to 2. 2 can talk to 3. 1 can talk to 3. Not only that, HQ could talk to this teleworker over here. This guy could talk to this guy over here. This guy could talk to this guy. This guy could talk to this guy. This guy could talk to this guy. Vice versa. You know, and as you see me drawing these lines, it should start to make sense that VPNs are overtaking the world. Now, there isn't a lot of drawbacks, but there is a few. Now, the drawback is VPN tunnels, the more you have, the more processor it takes on the router. The more processor on the router, the slower it's going to go. So, in order to have if you're going to have just a single edge router that's going to route your internal networks to your outside networks, it is smart to have a connection that you're going to be able to rely on, and a connection that's going to be able to be scalable. Well, the nice thing about VPNs is wherever you have an internet connection, you can bring up a VPN. So he can bring up an internet connection, I forgot, from him to him. Or you could just go VPN to this guy and have access to everybody else, because he'll have connections to all the other guys. So however you want to set it up, well, that's fine, because it doesn't make a difference. The VPN tunnel, MPLS is big on this one. They came out with Layer 3 VPN, and that is a cool concept right there. I'm not gonna get into that, but that's basically where this is going to evolve to. But what this does is it allows you complete scalability. It's low cost. All you have to do, in most cases, what you're going to do, you're going to tell this guy to go to a certain web address. You know, say www.abc.com. We'll assume that the ABC is the company that we're network engineers for. And by going here, you are going to set up, you'll say login at the top, up here. Okay, login for corporate users. So the guy clicks on this button, it says login. He clicks on that and takes him to an HTTPS connection. And all he's got to do is enter his current username and password. So he enters his username and password, and then he clicks enter, submit, whatever you want to have on your web address or your web page, and that sets up a web VPN or an Ssl Vpn. What that does is it allows him to tunnel over port 80, which actually flips it from port 80 to port 443. So it's secure internet over the web. So he's able to tunnel this way. And then once he's here, he's VPN'd in to the HQ router, or actually the HQ network, and then HQ network has connections to all these guys. So what ends up happening is he can go click on, say, you might have a link to, say, branch 1's file server. So he clicks on that, and that sends information across the internet to branch 1, grabs branch 1's traffic, and then brings it back. You don't have to worry about any of the other stuff that lease lines do with being restricted on speed, because you can configure a GRE or an IPsec VPN tunnel to go as fast as the circuit speed you want to spend the money for. So if you have a 30 megabit per second circuit that you're, say for instance you're paying, say $600 a month for 10 megabits. Well, you can have that 10 megabit section set up, and he can just come in, grab that file, it'll hit here, and it'll come back down here. Or you can set up a VPN tunnel to him. Or you can have all their information replicate over to HQ. Or you can have all the information on HQ replicate to the branches, or vice versa. You can have R1 or branch 1, 2, and 3's traffic or information over on HQ, and vice versa. So you can go to HQ. It's a one-stop shop. You go to one place, it already has the information, and this guy's already got dedicated connections maybe already, and they don't want to get rid of it. They just have like a VPN backup, and you can go that route. Now, there is a couple of caveats with that. There's some security that needs to be put into place, and what you need to worry about is this. There's encryption. There is, let's see here. there is security, there's key management, and there's security protocols. AH and ESP, authentication header, and encapsulating security payload. These are your VPN protocols. This is what's going to be the security algorithm to secure communications. So that's what you're gonna have a connection across the internet. That's what you're gonna use to get there. That's what's gonna be encrypting the VPN tunnel. Now, to guarantee you're gonna be able to get across, you're gonna have, say, an ISACAMP or an IKE, or which IKE is Internet Key Exchange, ISACAMP is Internet Security Association and Key Management Protocol. You can have an ISA-SA, so you're going to have an ISA-SA crypto tunnel. You're going to set up a crypto tunnel, and that crypto tunnel is going to encrypt all of your data as soon as it hits the tunnel. So the idea is you're going to exchange key information here with this guy, and what will end up happening is this guy will download a VPN application, or typically it's like Cisco's AnyConnect VPN client, and that will download, and that's what will actually allow you to tunnel through, because at that point you're going through the tunnel for all your communication. Then you have your data encryptions. Your data is secure, to make sure that everything is secure and not going to go anywhere. There's DES, triple DES. There is AES, which is like the mother of all security standards. There is MD5, which if you configure a secret password in Cisco iOS, that's what it's using, is MD5, Message Digest. Then there is SHA-1. When I talk about the Shah of Pakistan, we're talking secure hashing algorithm, standard 1. So all these things come into play. So this guy is what encrypts the tunnel. This guy right here, or actually I should say IKE, is what verifies, it says you are who you say you are. Triple DES is what makes sure that the information that's going across stays intact and doesn't get compromised. So as long as you can understand that, that's all you really need to worry about. I'm not going to get into fancy, animations to watch you see, or let you see how it works and all other stuff like behind the scenes. I won't configure them. They're complicated to configure, very complicated. GRE would be the first thing you would do. So you'd set up the tunnel across the internet, set your encapsulation, and then you would encrypt it. So then you would, the router would have to set up the crypto keys and stuff like that. So it's a little time consuming. I've never actually done it myself, so I'm just going based off of what I've seen. So to verify that it's working, you can do a show crypto. ISA SA, and then I'll tell you what it'll be public IP addresses. So you'll see your IP address here, another IP address here. Then you'll see two different things. You'll say QM idle. That is a Q. Idle. And then you'll see MM no state. This is the one you want. That means that the tunnel is up and working. If you see MM no state, the tunnel is not up. Well, the tunnel might be up, but it's not encrypted. The crypto tunnel has failed, so you won't be able to get across. The GRE tunnel itself might be still up, but the encryption might not be working. So you'll have to do a clear crypto session, a clear crypto remote session, or session remote, and then the remote public IP address. And then you do that from both sides, you're good to go. So not a problem. It's really, really simple. But I just wanted to give you an idea of what a VPN was like, and go from there. So not a lot to it. I know this is kind of like not the greatest example, but it's the best I can do with not having a lot of experience dealing with them. So I hope this has been informative for you, and I'd like to thank you for viewing.